Hi everyone, this is Toby from Resagratia, and I will be the one taking you through data case 002 today, right? I have the privilege of um, walking you through my solutions for this particular data case, my movies dilemma, it's called. Let's have a look at the questions to begin. It looks like this. It says connect to the box office mojo website affiliated with IMDb to retrieve the top 1,000 lifetime grossing movies. All top 1,000 movies must be retrieved in an automated fashion. It means no manual like inputs as much as possible, right? Design a dashboard in Power BI to display the total world lifetime gross, split into domestic and foreign. And C here says identify movie remakes and display before and after lifetime grossing value in dollars for each movie release. There's a cash reward. This is gone, right? Like, let's look at like my solution, right? Like how this looks so far. So it looks like this, right? Total grossing movies here split into domestic and foreign, right? About 37 to 63% split. And then the movie remakes have been identified, right? You can see a couple of them from Lion King all the way to Addams Family. The before and after is very clear. Of course, some made more money before, others after. With like for instance, Ghostbusters, unfortunately, made more money before than after. Um, while someone like Jungle Book made like 5 times the amount of money it made when it first released its first then the first year it was released in 1967. So that's pretty much it. And in terms of tables, look at that. I have 3 tables. One is, or 4, the measures table, of course, that's standard, just a list of measures. The movie remakes, after identifying the movies, the year they were, and then their before year and their after year. And then there's a table called movies aggregate, which is just the list of the 1,000 movies with an additional column here that just tries to identify whether a movie that has been remade, whether that year was before year or the after year. There's a interesting DAX function here. I'm using related, helps us to identify that. So I'm gonna move along, right? And get things started, right? Let's look at how we made this. Before we continue, our data cases are sponsored in-house now. It would be really nice if you want to be a sponsor, either as the money bag or as the data contributor. Please reach in. We're doing really, really great and exceptional work empowering students and professionals with hardcore and soft data skills to help them excel in the future of work. That said, box office mojo websites. We have the box office mojo website here. If you have a look at it, it shows the first 200 movies, right? The first top 200 movies. You scroll all the way down. Yeah, it has like the first 200 movies. And if you go back up as well, you're able to move to the next page, right? So the next page looks like this. 200 all the way down to 400. Go to the next page. It also gives you a hint here, 401 to 600. At the same time, if you look at the web page URL, you see that there's a sort of offset that's changing. Right? So if you go into the previous page, you see offset 200. Go into the next page, offset 400. Final page, not final, 600, right? So it looks like this offset here is the key to helping to automate our processes. And if we can get the data into Power BI, right, such that it will, if we can get data into Power BI such that it will take the first page, retrieve its content, take the second page, retrieve its content, all the way down to the 5th page, and afterwards append them together, then we have pretty much automated it, right? And then we can focus downstream on the analysis and all of that. And Power Query is a great tool. It's a scripting tool is akin to Python. You can do very impressive stuff with it. So I'm going to jump into a new Power BI sheet. I'm going to discard whatever I had there before. And we're going to go into get data, web, double click on web. I'm going to go into the first page, which should be offset 0. I'm going to copy that, come into web, paste, close. So at this point, the Power Query engine is connecting to that web page, trying to locate some HTML tables, trying to parse them and extract relevant information in a structured form. And that's what we're waiting for. Okay, so table 1, nope. Table 2, yep, that looks like kids. 3, nope, so it is table 2 then. Check that, and then we're going to transform data. So then we'll bring that into Power Query and see how we can manipulate that. Okay, so I'm going to go into Advanced Editor. Simply is connecting to a source. It's extracting the HTML table in that source, and then it's promoting some headers. Very simple step. Then how can we like put this into a loop? In Python, it would be akin to just like writing a for loop, right? Or a while loop. You have a set of page numbers or a range that goes from 0 to 1 to 2 to 3 to 4. And whenever it's 0, it's going to be 0 times 200 to get the page number. If it's 1, it's going to be 1 times 200, which is 200 to get the page number. 2 by 200, 400 to get the page number. So I'm just going to copy this and let's try ChatGPT. This doesn't work in time. Just going to move on. Let me show you a series of like prompts I'd written earlier in the past. Just very quickly. It says, I want to retrieve data from a web page with multiple pages in Power Query. The base URL is this. The offsets go from 0 to this to that to that. And write a script in M to iterate through the pages and retrieve the data in the HTML in one table. It wrote something, wasn't enjoying it. Says, I apologize for the oversight. I ran into some error. I think, and then I wrote a more improved prompt. Says, hi, appears the code ran into errors. Can you ensure that the iterator loops through the specified pages, retrieves the HTML page on each page before appending the data to get the, okay. Then I gave it this item, say source equals this. And then it brought out, I see you have the code to retrieve the data from the first page to extend the script to retrieve the data. Okay, so it brought out this, and then I modified it. I said, hey, can you make sure, can you modify the script to take in a variable called number of pages such that the offset for each URL will be calculated from the value of number of pages. And then I said, example, if number of pages equals 1, then 200, etc. And then it brought out this guy, right? Where it's connecting to source. Anyway, let's just try a prompt by ourselves, right? To say, hey, say, hi, you know what? I'm just gonna delete or just start a new chat. And I will say, hi, I want to connect to a web page in Power Query to retrieve data from the HTML page. To retrieve from the HTML table from HTML table contained within the So the base URL is this. Or you can say I have written this code so far, right? Then you can say this is the base URL. The base URL is this. Can you write a script to iterate through the pages by taking in a parameter called number of pages that goes. Can you write a script to iterate through okay, then you can say number of pages will range from 0 to 5, such that and will be used to generate the offsets for the base URL. The offsets for the base URL are 200, 400, 600, 800, etc. Let's try that. Let's see. So it says refer to the pages by taking and generate the offsets for the base URL. You can modify your Power Query scripts as follows. There's a list that accumulates at the end. Current page by 200, get current page by 200. This looks like a neat function. The only thing I might modify here is when it connects to this source, the web browser content, it tends to get this extracted tables, whatever it extracts wrong, tends to get it wrong. But let's have a look at it, right? Let's have a look. Let's copy the code. Let's go into Power Query. Let's go into a new source like this, blank query, and paste it. Go into Advanced Editor. I'm going to copy like this, and I'm going to paste it. Seems no errors are detected at the moment. Number of pages 0 to 5. Let's see. Okay. 999 plus rows. Can we get the maximum of this row count? And just do a, what is it? Max. List.max, I think. 1,200. So there are 1,200 rows here. Makes sense because this, let's go back here, because this in the code, in this list, it goes from 0 to 5. So we can just modify this to say, hey, 0 to 4. And this is actually like another neat way. The one I did before was probably like twice the length of this. I think I created a different function. And then this number of pages, like this 4 here, you can make it a parameter. So it's like n, you know, just like type 4 or 5 somewhere else. But this looks like it works. So I'm just going to change to 4. 0, 1, 2, 3, 4, 1,000 rows. And if we go back into this, that's weird. How is this still showing? Two hundred and one, 203. I think it's still showing 1,000. Like, really? Let me see. Don't want that to take too much of our time. And then I'm going to jump to the next one. 0 to 4. Hmm. What happens if I change this 0 to 3? Why, like, 800 rows? Okay, so what then happened when it was 0 to 4? It should have been 1,000 rows. Or maybe it's this. Yeah, I think it's that query that that ideally, if you really want to calculate the max, I think there are a number of ways you can do it. I I might even just like write a blank query, which is like this dot max, you can say equals to this dot max of um, the query one table, and then we look at the results. Is it the rank column? I think that's what it's called. 1,000. So, this is the query one table and then the rank column. So this one is a reference. The other one was more of a table and it was referencing the previous table that had 0 to 5. That's why the number didn't change. So deletes. Cool. So we have a very, very gorgeous query that has been done. It's been automated. I'm going to delete this guy here. Table 2, delete. That was just like the first 200. And here we can call it, I think we have some transformations to or not. This has already been extracted for us as a value, as a currency. This is stored as a, look at that. This is stored as dollars, as text. We need to change that. Foreign works. I mean, I'm just wondering why whatever foreign lifetime, world lifetime, domestic lifetime. So we have some issues here with foreign percentage. We actually don't need those like percentages. I tend to take them out because they're all calculations and you can always do them inside like DAX. So whatever was used here to extract this guy, right? And these are like so many different values. Should also be used here from the advanced editor. Let me see. Domestic lifetime, world lifetime gross, currency.type, domestic lifetime gross. Why did you not do currency.type too for it? Like so, right? Similar to this. And the other one too is foreign lifetime gross, currency.type, right? So we can do that. Let's see. Nice. So you got the currency all the way. I mean, of course, you can see applied. I just think it's a bit neater here. And then there are some errors here for domestic lifetime gross. Why do we have some errors? Let me go to the results table. I'm going to results here. Let's see. So there are some errors on domestic lifetime gross. That's the one that I applied now Okay, I'm just gonna see. I'm just gonna go back and change it to what was it? So it's domestic lifetime gross, right? I'm gonna go back and change it to type text, and then I will split the item afterward. Domestic percentage and foreign percentage we don't need. Right click, remove columns. So this guide is as text. All I'm going to do is I'm going to take out the um, text after dollar, which will be the delimiter. I'm going to go to transform. And I'm going to go into in transform, extract text after delimiter. And in text after delimiter, the delimiter is dollar. I'm going to click OK. Okay, now I can change it as well to something like this. Looks like it's taking some time to process this, but it's done. And we have a clean table. Now, what I'm going to do is I will rename this as movies aggregate. And then I want to identify like the movie remakes, right? Okay, there are some empty values in domestic lifetime because there are some movies that are foreign, right? Maybe they didn't like gross domestically, etc., etc. I'm hoping this doesn't run into issues again. For some reason my system is slowing down. And I'm going to stop sharing my camera so you can focus on the work. Okay, cool. So I think this is done. What I need to do is just to create like movies aggregate. And for that, I can actually just do a reference to this. I'll put a reference. And then in a reference, I'll group the tables. I'm going to say like group by, right? Um, the grouping is by the title, right? So for each title, um, right? Can you count the number of like, can you count the number of movies that appears, right? So it's like, can I say movie count, something like that. You can say number of movies. And then I'm going to aggregate again. I'll create the before year, and it's going to be a minimum operation on the year. And I'm also going to say the after year. And this will be a maximum operation on the year for each movie. Let's click OK. Okay, so of course, most of the movies will come out as one. We'll filter for movies that are greater than one, right? The number of movies is greater than one. Those would be like movies that have been made, right? Yeah, it has to be greater than one. It's possible that some movies are remade 3 times. So this be the movie remakes, the before year, the after year, and then the title of the movies. We can double click on this and call it the remake. So, and then come here and go into close and apply. By the way, I saw some pretty neat solutions for this as well, right? Some people created additional queries, like 5 of them, to connect to each of these pages with those offsets. Some others, or one other person, one other person actually wrote like the same list of pages, created a list of pages and applied a custom function that loops through those pages. I thought that was pretty neat as well. it will do you a lot of good to know a little bit about like how Power Query works. Um, but yeah, that's pretty much it. Whilst we wait for this to load, the next set of steps will be, hey, we've identified the movie remakes. Can we put them together in a chart? And can like first we'll create the model, right? So we want to link the movies aggregate with the movies remake, and then we can quickly drop our charts. We might also have to like create some measures. Anyway, let's have a look at our this. We can create a model here. Should be like a one-to-many. Yeah. So that works. This is fine. And then, well, let me have a look at that again. Okay, cool. Title. And this is going to be a very, very basic one. The title is analysis of 1,000 lifetime movies, right? Like so. And then I can make it 26 or 36. Oops, wrong one. 48, 36 is fine. Okay, I guess we'll have to extend it a little bit. Extend this a little bit as well. So I'm just going to do that for the top 1,000 lifetime. Why is it highlighted? And that's pretty much it, right? Can add the data source for total lifetime. For total worldwide movies, right? We can just either we write a measure. Again, I can just quickly create a table of measures right here. Okay, so measures is done. I'm going to right click. I'm going to create a new measure. I'm going to say total worldwide lifetime. It's pretty much just sum of the worldwide lifetime growth, like so, right? And we can put that in a text box like this. You should see the 4 billion or so. Okay, cool. We already marked it as this type of data anyway. Then we also need it to be split into domestic and foreign, right? 37% versus 62%. Of course, can drop it into a pie chart. Then you might want to calculate the total domestic and total foreign, or just drop them inside. For speed, I'm just going to drop this and then go into movies aggregate, and you drop domestic and foreign into um, this and this. You can quickly create that. But I guess what you really want to see is, so you can format it appropriately, make it look much better than how this is looking right now. Right? Make it look much better than how this is looking. Foreign is 62%. Yeah, that makes sense. Whilst this is that, yeah. I think you might not even need the what do you call it? The legend here, just remove it and make it a bit bigger. And data labels, what are you trying to show? Do you want to show all the labels, right? So you show like the sum of this. Once that shows, maybe you just want to change it to foreign. And then this is like domestic. So it's like, it's, more readable, if you get me. Then the last one is what is it? lifetime remakes. So you can come here, drop a cluster chart like so, right? Drop a cluster chart. And then go ahead and drop the movie remakes like x-axis and title. You know, it then starts becoming a little bit woozy, like, what's going on here? Like, what am I gonna add here? The before year, the before year, after year. Okay, but maybe not. It's actually like the sum of lifetime growth, right? So you can say total lifetime growth, and you put it in the y-axis, right, for these guys. But then how are you gonna split it into before and after year, which is what we need to do, right? So you have all of these guys here. Of course, I want to remove like where title, is not blank. So select all and you remove blank like so. Um, yeah, okay, that took some time. So you remove blanks and this is cool, right? Except how are you going to split this, right, into before year and after year? Um, it's very nice to create a category on the movie remakes table. On the um, there are different ways, right? But I think this is like very, very breathable, right? On the movie aggregate table. So right here. And there's a, you know, there's a related uh formula, right, that you can leverage because you have a nice model to say, hey, return, like when you look into this movie remakes table for each guy, return, whenever you see that it's the same title and the year matches the same year, right? Um, return before, right? Otherwise, if you look into it and you check the after year and the year matches it, then return after. And I think that's what this code does, which and I call it like before and after check. So it looks like this. I'm gonna say new column over here. Right. I'm gonna say new column and I'm going to paste this formula here. We can't find this now because I need to rename the table. The table is called movie remake. It looks like this. Sorry, I got like I just want to have a look at. So title is title. Okay, so this is it. I'm just going to rename this. It's called it's like the tables are actually movie underscore remake, which is crazy. And then this one is movie underscore aggregate, and it goes like that. Yep. So it says, oh, like check this related guys, right? If the related value, right, for the title matches and the related value for the year, right? Before year in this movie remake matches the year in this table, then definitely that's the before year. Else, right, you do the same thing. If it matches, otherwise the after year, then that will be the after year. And that's what this formula does. Um, Yep, that's pretty much it. And if you do like this, yeah, it checks out, right? So now, whenever it matches Lion King, the title and the year together, it will return, oh, the after year, if it's the after column that it matches. Otherwise, it will be the before year. And I suppose this could literally just be like if like we could literally just change it to if it's not before, right? If you match before and you know it's not that, then otherwise it should just return after, right? Um, that could work as well. In fact, that will work and make this like um, much easier. Okay? I believe. Okay, then everything is matching. No, it didn't work. So I'm going to leave it like that because it means you have to like check for H again. And that does the magic. And this is, I realize, it's taking like a little bit longer than expected. So we'll bring our before and after, we'll put it into legend to split this. What's going on? Okay, cool. And yeah, like of course I would want the before to show before the after. So you can sort this by, in this case, descending order, I believe, right? So B before A, and that works. So before and after, before and after. And voila, that brings us to end of the data case 002. The final thing there is you want to find out, oh, what's the total amount of money that movie remakes have garnered. Um, there's there, you can run like a sum if the movie is in this movie remake, right? Then you sum it, or you can even use a card, very simple card visual, and in the card visual, you drop this, and then you drop the total amount. So this is total amount of all the movies, but then how much have movie remakes made in total? And just filter this. You can filter this for title, right? Of course, like select all, title must not be blank. That's pretty much it, right? These are the titles in the movie remakes, right? So this is, yeah, a song, a title. Anyway, you get the gist. That's it for data case 002, my movie's dilemma. Let me know how you or what you think about this. Was it exciting? Differently? Um, and watch out for data case 003. If you'd like to sponsor, as I mentioned, please reach me. Very awesome. That's it from me. Ciao.